Hello students. In our vehicle dynamics class, we were discussing about steady state cornering and we have covered two parts of the video. This is the final part of the steady state cornering. Till now we have discussed some of the important formulas. One of the most important formula you have to remember is cot phi minus cot theta is equal to C upon B, where phi is the angle of outside lock and theta is the angle of inside lock. So B is the wheelbase and C is the pivot center. So there are some more relations that we have discussed, that is sine alpha plus theta is equal to y plus x upon r, sine alpha minus phi y minus x upon r. These things we have discussed in the previous parts. So when we add these two relations, you will get sine alpha plus theta plus sine alpha minus phi is equal to 2y upon r. That is 2 sine alpha. So these are the some important relations. So let's start the question. The front axle of the car has pivot centers 1.1 meter apart. It means that your C, that is pivot center, is 1.1 meter. This is your, in this diagram you can see this C length pivot center is 1.1 meter. Length of each steering arm is 150 mm. So your steering arm, that is RA, this length small r, and SB small r, this length is given as 150 mm. You convert it into meters. While track rod is of 1 meter length, so your track rod, this AB track rod is of 1 meter length. Calculate wheelbase for perfect rolling of the car wheels when inner wheel stub axle is at 55 degree to the rear center line. So it means that your inner wheel stub axle means this line makes angle 55 with the rear center line, means this line and this line has angle of 55 degree. If this is 55, then what will be theta? Theta will be 90 minus 55. So 90 minus 55 means theta will be 35. So your theta angle of outside inside lock is 35. So given data has been written, first of all you have to calculate wheelbase. So see from the relation where we can find out wheelbase. Uh, this is the relation, that is cot phi minus cot theta is equal to C by B. From this relation you can calculate wheelbase because C is given to you, theta you have 35, you need to calculate phi to get the wheelbase. So how will you calculate phi? So we will apply the relation sine alpha is equal to C minus L by 2R. So you can see in this triangle, this is your triangle. In this triangle, sine alpha will be applied. Sine alpha will be opposite side over hypotenuse and opposite side is y, and y is C minus L upon 2. So C minus L upon 2 and hypotenuse is R. So sine alpha will be C minus L upon 2R. Put the values of C, L and R, you will get alpha. And from this alpha, you can put this alpha in this relation to calculate phi. So apply the relation sine alpha plus theta, sine alpha plus theta plus sine alpha minus phi is equal to 2 sine alpha. So from this relation, you can get phi, and from the phi value, when we put in cot phi minus cot theta is equal to C upon B, you can easily calculate wheelbase. Okay, so this completes this numerical. One of the more concept I want to discuss today is about roll axis. So what is roll axis? It is also related to directional stability of the vehicle. An axis about which an aircraft or vehicle rolls is called roll axis. The vehicle tilts or rolls about an axis due to the action of side forces on it. This axis is called roll axis. So actually, when you move in a vehicle, when you drive a vehicle and your vehicle starts to roll sideways, then about this axis, about which axis your vehicle starts to roll, is called roll axis. its position depend upon type of suspension used for both rear and front wheels. The roll axis is an imaginary line between the front and rear roll centers. So to determine what is roll axis, you have to know what is roll center. So roll center is a theoretical point around which the chassis rolls and is determined by the design of suspension. Front and rear suspensions are different roll centers. So the amount that a chassis rolls in a corner depend on the position of roll axis relative to the car's center of gravity. So now understand what is roll center. You can easily understand from this diagram. Now this is your vehicle, and now see, line A is parallel to upper arm. This is your suspension system, and this upper arm, this is line A. This line A is parallel to upper arm. This is your upper arm, and line B means this line is parallel to lower arm, and these two lines meet at point IP, this point. And there is another line C which goes from the wheel contact point to the IP. This C line goes from the contact point of the wheel to the IP, and the C line meets the center of the car at this point, and this point is called roll center. Okay, so similarly for the front tires, the roll center is this. Similarly for the rear tires, there will be some roll center, and the line which joins two roll centers is called roll axis, and about that axis your vehicle will roll. Okay, so this rhombus represents center of gravity of the vehicle. So again you can see upper arm line A, lower arm line B, both lines meet at IP, and this is your contact point of the vehicle with the road, and this line C also passes through IP, and this C meets the center of the vehicle, and this point is called roll center. And the roll center of the rear wheel and front wheel when joined together becomes the roll axis, and about roll axis your vehicle will start to roll if it is not stable. Okay guys, that's it for today. Rest of the topics we will discuss in the upcoming videos. Thank you.